So good morning, my name is Cecilia Mwansa, HOD Natural Sciences, Helen Kaunda Secondary School. With me here are apparatus which I am going to use, or which we use when we are determining the volume of irregular objects. So to determine the volume of irregular objects, the methods known as displacement methods are used. So there are two ways in which the volume can be determined. One way, we can use the overflow can and the measuring cylinder and the irregular object. The second method, you can use the measuring cylinder with a known volume of water and an irregular object. So I'm going to demonstrate how we determine the volume using both methods. So I'll start with the method where you use a measuring cylinder. So in this measuring cylinder, there is water, and the volume of water in the measuring cylinder is known. So the amount of water which I placed in the measuring cylinder is 30 cubic centimeters. So I'll take note of that volume of water and I'll record it as volume 1. The next thing that I'll do is I'll get an irregular object. In this case, I am using a small stone where I have tied a thin string. And when that is done, I'll gently and slowly lower in the stone into the measuring cylinder as we make observation of what happens to the volume of water. So what happens to the volume of water is that the level of water rises from where it was to another level. So the first volume, I said we call it V1. And now because the volume has changed, the second level we are going to call it V2. So for us to find the volume of the stone, we are going to subtract the second level minus the first level, or V2 minus V1. So what we are going to find is equal to the volume of the stone. So in short, we are saying the volume of water is equal to the volume of the stone, is equal to the volume of water that has been displaced by the stone. The volume of the stone is equal to the volume of water displaced by the stone. This is method 1. Second method, we are using a measuring cylinder and an overflow can. I'm sure you are able to see from the arrangement that the spout of the overflow can has been placed in such a way that there is a measuring cylinder just below that spout. So I poured some water into this overflow can, and the water, of course, adds to overflow. I waited for the water to stop overflowing. Then I am going to measure the volume of this stone using this method, which is of course also known as a displacement method. So I will slowly tie a thin string around the stone. When it is firmly tied, I'll get the stone and I'll lower it into the overflow can. I'm sure you can observe that the water is overflowing into the measuring cylinder. Okay, so you should wait for all the water to move or to flow into the measuring cylinder. When that is done, you can now get or remove the measuring cylinder. Okay, you go down and read the volume of the water that is collected in the measuring cylinder. That entails that you have found the volume of the stone, which is the irregular. So we are saying the volume of the stone is equal to the volume of water which has been collected in the measuring cylinder. Now, as we do this experiment, there are certain precautions which we must put in place. One of the precautions is that the string that we are using to tie our irregular objects must be as thin as possible, or the mass must be negligible. The other precaution is that whether you use this method or this method, when you are lowering in the stone in the overflow can or the measuring cylinder, the stone must be lowered in as slowly or as gently as possible, so that water does not splash. Because if water splashes, it is going to affect the volume of water that is going to be collected in the measuring cylinder, and consequently affects the volume of the irregular object which you want to determine. Thank you.